In this video, we're going to learn how to solve a system of equations. So system just means more than one. For us, it's going to mean having two sets of equations. So one of the ways we can do this is by graphing. So in order to graph, both need to be solved for y. This is solved for y, this is solved for y. So I'm ready to go ahead and graph. So we have negative 2x plus 2, so we're going to go ahead and graph that. And again, I'm just using my slope and my y-intercept in order to graph this. And we're looking for that intersection point, and it crosses at 1 and 0. Let's go ahead and put this in the calculator and see if that makes sense. So I have negative 2x plus 2 and 2x minus 2. Okay, that's what my picture looks like, so that makes sense. Now, we want to find this intersection point, and it may be hard to see sometimes. So this is how we find an intersection point. Second, trace, number 5 for intersect, and then we're going to hit enter 3 times until we see that word intersection. Intersection, so x equals 1, y equals 0, which is what we got. Now, if I didn't use this doing the calculator, or if I messed up somewhere, then we want to see if we can check our work and see if that answer makes sense. So we're going to go ahead and plug this in for x and y into both equations to see if it's a solution to both, because it has to be a solution to both in order to be a solution to the system. So my y is 0, my x is 1. So let's go ahead and simplify this. Negative 2 times 1 is negative 2, plus 2 is 0. 0 equals 0? Yes. So it is a solution to this first one. Let's plug it in that second one. So we got 0 equals 2 times 1 minus 2. 2 times 1 is 2, minus 2 is 0. 0 equals 0? Yes. So we got a solution to both, so that means I did it correctly. All right, let's try one that's a little bit more complicated. So this one is already solved for y, but this one is not, so we need to solve it for y. All right, so we have this positive 2x, so I'm going to subtract it from both sides. And again, I'm going to write that x in front because that is slope-intercept form. All right, y is by itself, so now I'm ready to go. I'm actually just going to go ahead and plug this in the calculator, and then I'll just draw the picture on the provided graph. All right, so we got x plus 1 and negative 2x minus 2. I'm going to go ahead and hit graph. That's what my picture looks like. So it looks like, let's see, let's go ahead and find that intersection point. All right, so it crosses at negative 1, 0. So that point is right here, and I'm going to try to sketch this graph as best as I can. Okay, so we found out that our intersection point is negative 1, 0. Let's check our work and make sure that it's plugged in correctly. So we got 0 equals negative 1 plus 1. Negative 1 plus 1 is 0. 0 does equal 0. All right, let's plug it into that second one, make sure it works there as well. Negative 2 times negative 1 is negative 2, plus 0 is negative 2. Negative 2 equals negative 2. That's correct, so we did it correctly. All right, last example. So we're going to have to solve both of these for y in order to figure it out. Okay, so again, we're going to solve this using the box method. So we're going to start with this 3x, so we're going to subtract 3x from both sides. And again, we're going to write that x in front so that it ends up in slope-intercept form. Here we have negative 4 times y, so I'm going to divide by negative 4 on both sides. And then 1 divided by negative 4 is just negative 1 over 4. So this is how they simplify. So now I also got to solve this second one. All right, so I got this positive x, so I'm going to subtract it on both sides. Again, I'm going to write the x in front so that it's in slope-intercept form. Then I will divide by 4 to get rid of the coefficient. All right, so there's my both equations. Now I can go ahead and plug them in my calculator and graph them. All right, so we got 3 over 4x minus 1 over 4. And then we have negative x over 4 plus 3 over 4. I'm going to go ahead and graph that. All right, and then again, we're going to try to find that intersection point. So second trace 5. We're going to enter 3 times, and it gives me 1 and 1/2. So that would be about here. All right, so now let's plug that in and see if it works. All right, so I'm going to plug it in that first one, and we're trying to see if it's equal to 1. All right, so 3 times 1 is 3. 4 times 1/2 is 2. 3 minus 2 equals 1. That's correct. And then we got, let's see, 1 plus 4 times 1/2 equals 3. We already know that this is 2. 1 plus 2 does equal 3. So we know that it works in both, so we know we did it correctly.